Welcome to another episode of the House of Wolverine. This week we are going to take a look at the USS Gerald Ford's Advanced Arresting Gear, or AAG, which is how we recover aircraft during flight operations.
The main differences between Nimitz class and Ford class carriers is that hydraulic driven based machinery on the Nimitz class to now we're primarily off the ship's power. We store our capacitors up to 1,000 volts prior to an arrestment. That 1,000 volts is used through a motor generator, which kickstarts a shaft which spins the purchase cable drum to catch up to the speed of the aircraft, pretty much make the engagement a lot less strenuous on the equipment and the aircraft itself, along with the pilot. It's supposed to alleviate a lot of stress on all those systems and also reduce maintenance, reduce a lot of wear and tear. So in the long term, it's supposed to be more cost efficient. A lot less maintenance-driven machinery itself due to the hydraulic system. You're constantly replacing leaks, replacing packing to prevent leakage of fluids. With this AAG systems, with electrical-based, it's a lot more inspection-based criteria rather than corrective maintenance. So doing a lot of making sure things aren't wearing and tearing wrong or incorrectly, and if they are, you just gotta do a quick fix rather than just labor intensive compared to the Nimitz class. So during the recovery process, you have a cross deck pendant, which is on the top side on the flight deck, which is the tail hook engages. That's where a lot of the brute force has the impact on from the aircraft coming in 150, 170 miles per hour. It engages that cross deck pendant, which takes a lot of that force. The cross deck pendant is connected to purchase cables, both port and starboard on the ship, which run down and connect inside the engine room, which we're in right now. They never really connect downstairs. They only connect on top side. So when it's at tension, AAG has a system to where it's constantly kept tension so that it can be a certain height on the flight deck so the tailhook can't engage it. Once that tailhook engages, there's sensors that talk to each other inside the engine rooms on both port and starboard. And they call them encoders, right? Sensors, encoders. Once those encoders reach a certain distance, they lets the system know, like, hey, I'm having an arrestment. Proceed with your catch phase, which I was telling you about, that power that we keep in our cabinets up to 1,000 volts. That catch phase kickstarts a generator to about 5,000 to 6,000 horsepower, which turn a shaft that's connecting both port and starboard cables, purchase cables, to catch up with the speed of the aircraft. So it turns this shaft, catches up to maintain that speed the aircraft's coming in, feeds the cable out for it so that it's like a lot less strenuous on the system itself. So as it's feeding itself out, AAG has turned itself into not just a system that pushes energy out, but actually starts creating its own energy. The system, as the payout is happening and the arrestment's happening, it turns itself into a generator, starts creating its own power. So with our systems, they're able to store that power, use that power that it just created on the arrestment to retract it back. Retracting means it's getting the cable back off the flight deck downstairs onto a purchase cable drum where it's housed, and then ready to recover another aircraft. So it's that's what's kind of a unique feature, is that it not just uses the energy that we pull from the ship. We actually generate its own energy to help do the process also.